Okay, so this is one of my favorite questions because I wrote it, although it's almost identical to your web work question, which you also struggled with. So what you want to think about is if you have a function just like, let's take an easy one like that, right? F of 0 is 1, right? It's that value right there. But what happens to f prime of 0? Well, because when you take the derivative, you get rid of the constant, but then all these powers decrease. And so you're going to just get 7, right? Well, what about f double prime? Are you just going to get 3? Not quite. Almost. Because the first time you take a derivative, the 2 is going to pop down, and you have 2 times 3 is 6. And then the second time you take a derivative, then the x disappears. So what's happening actually is as you're taking derivatives, you're accumulating factorials. So if you have, a whole bunch of derivatives of this guy, it's going to look like this. 7 times 6, x to the 5th, and it's 7 times 6 times 5, x to the 4th, and so on and so forth until you get down to 7 factorial, and the next time you get nothing. But the trick is you're putting in 0. And that means all these terms are going to zero out. I mean, this is going to be 0, 0, 0, 0, all the way down until one magical moment you have this astronomical derivative, and then it's 0 again. So let's think about that. What does that mean? Okay, so what does it mean to be x to the 7th? Okay, so I could say f is equal to x to the 7th. It means f of 0 is f prime of 0, which is 0, is f double prime of 0, is f triple prime of 0, that's all 0, and f4 is 0, and f5 is 0, and f IV of 0. These guys are all 0, and then this magical one is going to be 7 factorial. And then we're going to go back to being 0 again. All the other derivatives are just going to be 0. Is that crazy or what? So all the derivatives are 0 except the 7th derivative, which is 7 factorial. So it's a little bit crazy. So you can tell what a function is doing by looking at the sequence of derivatives at a given point. And so what we're doing is we're looking at this crazy function. I don't know what it looks like, but it's an odd function. It's an odd-powered polynomial. So it goes off to positive infinity and negative infinity, and it wiggles in the middle, whatever the middle is. And the point is, if you sit at 0, you get different information than if you sit at 4. So if you sit at 0, you pull the information from here, from this way of expressing this function. And so you would just say minus 4147. The first two you get absolutely for free. You don't have to worry. But then you have to start worrying about the 2's and the 3 factorials and things like that. Okay? And so on and so forth. And then the 7th derivative is 7 factorial, and the 8th derivative is 0. Okay, but what about we've got a different way of expressing this function, which is we're doing x minus 4 as the new center. So 4 is the new center. So f of 4 is 77. And guess what? There's no x minus 4 square piece, and there's no x minus 4 piece. These pieces don't exist. So these guys have 0 derivatives there. Just like x to the 7th has 0 derivatives everywhere at 0. Elsewhere it has derivatives, right? But at x equals 0, x to the 7th only has something. X to the 7th has only one derivative at 0, which is non-zero. But if we looked at any other point on that curve, that's not true, right? So these things can change. Where you put the roots changes where the 0 derivatives are, and I mean which depth of 0. Which depth of the 0 is a 0. Anyway, so what's going on here is we finally have something to talk about. This 3 matches with this 3, so you say, aha, 2 times 3 factorial. And then we have no 4s, no 5s, aha, we have a 6. So it's going to be 6 factorial times 3. And then this guy's, we're going to get 7 factorial for the 7th derivative. But we already knew that, because once you get up to the 7th derivative, the entire function has this common 7th derivative. For any polynomial, there's got to be the last little ray of light before the whole thing vanishes, right? So it's going to be constant whateverth derivative for the whole entire function, and then after that, the function is just 0 forever and ever and ever. No more derivatives, it's just 0. Okay, so that's how this one works.